Detailed report on the Asender engine. 1. Introduction. The Asender engine is a cutting-edge internal combustion engine, ICE, designed to maximize efficiency and minimize energy waste. It adopts an opposed piston configuration, a concept that reduces mechanical complexity and eliminates the need for traditional components like cylinder heads. With potential applications ranging from military drones to construction equipment, this engine stands out due to its simplicity, high efficiency, and ease of maintenance. 2. Design overview. The Asender engine follows the opposed piston architecture, which utilizes 2 pistons per cylinder, moving in opposite directions. This configuration provides several advantages over traditional ICEs, such as improved thermodynamic efficiency, better balance, and lower part count. Key design features. Opposed piston configuration. 2 pistons in a single cylinder eliminate the need for a cylinder head and associated heat losses. Few parts. By minimizing moving components, the engine is easier and cheaper to manufacture and maintain. Lightweight and compact. Its compact nature makes it ideal for weight-sensitive applications like drones and unmanned vehicles. 3. Efficiency and performance. The Asender engine is projected to achieve an unprecedented efficiency of 58.5%, significantly higher than conventional engines. This is largely due to the engine's ability to address traditional causes of energy loss. Reduced heat loss. The lack of a cylinder head reduces thermal losses. Improved combustion. By refining the combustion process, the engine maximizes the conversion of fuel into mechanical energy. Mechanical efficiency. Fewer moving parts reduce frictional losses, leading to smoother and more efficient operation. These design optimizations could make the Asender engine one of the most efficient ICEs available, ideal for applications where fuel efficiency is paramount. 4. Potential applications. The simplicity and high efficiency of the Asender engine make it well-suited for a range of industries and applications. Drones and UAVs. The engine's compact size and light weight are advantageous for drones, where every kilogram saved can extend flight time and payload capacity. Military applications. Rugged and easy to maintain, the engine could be ideal for military drones and unmanned vehicles operating in remote or hostile environments. Construction and agricultural equipment. The Asender engine's durability and low maintenance make it a natural fit for heavy-duty equipment like bulldozers and tractors. Automotive and trucking industries. With its high efficiency, this engine could help reduce fuel consumption and emissions in commercial vehicles, a key goal for many automakers and logistics companies. 5. Market potential. The Asender engine has a strong value proposition for companies focused on efficiency, reliability, and cutting-edge engineering solutions. Key markets include automotive. As automakers shift towards higher efficiency solutions, particularly in light of tightening emissions regulations, the Asender engine could fill a niche for high-performance, low-emission ICEs. Energy and oil companies. Companies like Aramco may be interested in adopting the technology for their own operational equipment or licensing the engine to reduce emissions in the oil and gas sector. Military. The potential for enhanced endurance and performance in unmanned aerial and ground vehicles makes the Asender engine attractive for defense contractors and military organizations. 6. Manufacturing and maintenance. The Asender engine's simplified design means it could be produced at a lower cost compared to traditional ICEs. Additionally, fewer parts translate to less frequent maintenance, lowering total cost of ownership, TCO, for end users. Key advantages. Ease of manufacturing. With fewer components, the engine is easier and quicker to produce. Low maintenance. The simplified design and robust construction ensure that the engine requires minimal upkeep, reducing operational downtime. 7. Challenges and next steps. To bring the Asender engine to market, several key challenges need to be addressed. Testing and validation. The engine's efficiency claims need to be rigorously tested in real-world conditions to ensure they meet or exceed expectations. Partnerships with manufacturers. Collaborating with engine manufacturers and automakers will be essential to scale production and validate its commercial viability. Investment and funding. Securing investment will be key to further developing the engine and bringing it to market. Companies like GM, led by Mary Barra, and oil majors like Aramco are potential candidates for collaboration or funding. 8. Conclusion. The Asender engine represents a significant leap forward in internal combustion engine technology. Its high efficiency, reduced complexity, and wide range of potential applications make it an attractive proposition for various industries. With proper investment, testing, and strategic partnerships, the Asender engine could revolutionize the ICE market, offering a more sustainable and efficient alternative to traditional engines.